Hey everyone, Nick Dearbird is here teaching you financial modeling. Today we're going to be adding internal randomness to a Python model. This is part of our lecture series on probabilistic modeling. So we've already covered the internal randomness material, just adding randomness somewhere within the core of your model. And we also already looked at an example of how we can add that to an Excel model. So in this video, we're going to explore the Python side of working internal randomness into an existing model. And I just want to preface this with when you use internal randomness, it definitely makes a lot of sense to plan for it at the outset of the model. If you have to go back and rework a model to add internal randomness, it can require having to redo a lot of the logic. So try to plan for if you're going to use internal randomness and add it from the beginning, but we're going to show how you can kind of rework a model to add it in those cases where you didn't plan for that. In a lot of cases, you can just use Monte Carlo simulation to do the same thing without having to completely rework the logic of the model. But let's go ahead and look at this example with internal randomness for Python. So we can go over to our existing dynamic salary retirement model we've built out in prior videos. And I'm just going to quickly restart the kernel, run all cells so that we have everything defined. And we're going to build this out at the bottom of the model. Um, so this does require substantial rework of what we already have. And so, normally I would recommend just saving a separate copy of the model and then just going in and modifying the code which is already there, or even better, use version control. But here, just to have one comprehensive example, I'm adding it on the ends, and I'm going to copy paste some of the prior logic to help rebuild it with internal randomness. So for this exercise, I'm going to consider the same situation that we had in Excel, um, where we have three different states of the economy: recession, normal, and expansion. And each year, we're randomly put into one of these states of the world based on the probabilities of those states. And the inputs are going to align with that state of the world. We're going to go a little bit further than the Excel exercise, which just looked at the interest rate and the savings rate. We're going to go ahead and do it with all the different inputs, aligning them in the recession, normal, and expansion cases. So the first thing that we want to do is set up the new inputs for our model, because now we're going to have different inputs for each possible case. And we have to have a new structure for that as well. So I'm going to copy this. Again, if you were going to do this, probably just modify your existing with it being backed up. And then now we're not going to just have a single number for each of these. We're going to have multiple numbers corresponding to the different states of the world. But let me add the recession probability. Let's say that's 20% by default. And let's add the expansion probability. And one additional input we can add as well is the names of the different cases that we're looking at. So we can have recession, normal, expansion, economy. So we'll go ahead and modify the existing inputs now, so that we have one for the recession, one for the normal, and one for the expansion. And you'll notice here I used a tuple for the inputs, not a list. The reason that I'm using a tuple over a list starts to get a little bit outside of the scope of this class. It has to do with the mutability of a list, the fact that it can be modified in place, and that can actually change the default values of your inputs after you've defined them. But we're not going to really discuss that in detail. Just know that if you want to put multiple values of something in your data class defaults, then use a tuple rather than a list. So I'm going to convert all these to tuples, and here, let's say 40,000 in the bad, 70,000 in the good. And then for promotions, let's do, or it takes longer when we're in the recession every 8 years, 4 years in the expansion economy. We're going to convert the cost of living raise. Let's just do 1% for the bad economy, 3% for the good economy. For the promotion raise, again, that's going to be lower here in the recession and higher in the expansion. And for the savings rate, let's do here go with the individual who is financially constrained, so they're not able to save as much in the recession. And then for the interest rate, we can go with 3% lower interest rate for the recession and a higher interest rate for the expansion. Desired cash, I'm going to leave as is because the amount of cash you need to retire shouldn't really be affected by whether you're in a recession or expansion period. So now we have our new model data, which has tuples for most of the inputs rather than single values. So most of the rest of the work is just going to be taking the existing model and adapting it to work with these tuples and pick the correct input from the tuples. But first, we need to be able to randomly pick whether we're in the recession, normal, or expansion case. So I'm going to write a function to do that. And for picking recession, normal, or expansion, I'm going to use 0 to represent a recession, 1 to represent normal, and 2 to represent expansion, because then we can just directly use that number to index these tuples. And certainly you would want to write that up in the docstring of the function and include that in the Jupyter description as well. And you can see all that in the completed example on the course site. We're going to need to use the random module to pick these random discrete variables. So I'm going to go back to the top and I'm going to import random and come back to the bottom. So first thing we can do is calculate the normal probability, which is just going to be 1 minus, right here, let me do data equals model data so we can write our logic with data. Data dot the recession probability minus data dot the expansion probability. And now we want to get that 0, 1, 2, so we can call that the case number. And we're going to use the random dot choices function in order to pick that. So 0, 1, and 2 is what we're picking from. And the weights for that are going to be first the recession probability, and then this normal probability that we just calculated, and finally the expansion probability. And we just want a single case number, so I'm going to extract that from the list by indexing it with 0. And then we can take a look at what we got. And as I run this, we can see that we're getting different cases, 0, 1, and 2, getting randomly picked. So now we can convert this into a function. Def get economy case number. It takes the data and then just indent this and return the case number. And then this should still work the same way. Yep, we're still getting random different economy case numbers. So then we have to take this and our new inputs and kind of rework the model. So I'm going to go and just grab all the main model functions, the salary at year function. I'm going to go and grab the cash saved function, cash saved during year. Again, you know, if you're doing this with your own model, just back it up and then you can just directly modify things rather than having two copies of your code. You generally do not want to have two copies of your code because that creates a big maintainability issue. But we're just, you know, doing this here for sake of example. So now I've got all the main functions from the model. So I'm going to look at reworking these. So I'm just going to, you know, take out the main logic here so I can try it out. So if I go and run that, you can see that it already is not working appropriately, right? And that's because we've changed the structure of the inputs. They don't work the same way anymore. So now it's trying to do math with a tuple when it should have been an integer. Or it should have been a number. So what we can do is we can think of structuring this as, you know, basically we're going to have in this final loop where we go over each year, we're going to be picking the case number within that year. And then we can pass that case number into the other functions so that they can work with that same economic case. So I'm just going to go ahead and call case equals get economy case number on the data. And now I just have case defined. Later I'm going to remove that. It'll be built into only the function, but this will help us build out this logic initially in the cell. So the problem now, you can see it's pointing to this line with data promos every n years. Because now that's a tuple and not a single number, you can't divide a number by a tuple. But if we pull out the case right now is the expansion economy, and if we pull out the expansion economy, then yeah, that's getting the input from the expansion economy, having the promotions every 4 years rather than 5. So all we've got to do to fix this part is put the case there. And now we run this again. It still doesn't work, but now we can see it's complaining about the next line. Again, another error about using a tuple, because again, we want to be using numbers here, but these are all tuples. So we can do the same thing with starting salary, with cost of living raise, and the promotion raise. And now let's try this again. And now we can see that we do indeed get the salary appropriately now. So I'm going to take this logic and I'm going to now bring it into this function. Make sure to return that salary. And let's move on to the next function. So, well, let me run this so that the new salary at year is defined. Oh, and there's one more thing we need to do. We need to pass the case into this function as well. So it's not just using this specific case that we pulled one time. We want it to be able to take whatever case that we want to use. So now we can come to the next function, cache saved during year. Take a look at that logic, and let's try to run that. So we'll see the first error here coming up on the first line, the salary year line. Now we're missing the case argument. We want to pass the case there as well. So then we run it again, and now it's failing at the second line. And that's because here we need to look at the case as well. And now it works just fine. So now we can take this logic, we can bring it over to cache saved during year. We want to make sure that we return it, and we want to add case as an additional input. Rerun this so that this function is redefined. And now let's work on the next one. We're getting close. So now run that. We can see same pattern as we saw before. We're not passing the case here, so let's do that. And now it's failing on the second line where we're not pulling the case interest rate. So now this is working appropriately as well. We can go and bring that into wealth at year and return that and add the case as an additional argument. And so now we come to our final function, the years to retirement function. Make sure we rerun this to define it. And now bring this logic out here. So when we try running this, so first thing, print output's not defined. So I'm just going to add that print output. Let's make it true. And then we see same pattern, wealth at year, we're not passing the case. But here, now we've gotten to the main loop. We don't just want to use the existing case, which we had as an example case. We want to actually get the case in each year. So the case here, we're getting within every year, and we want to pass that here to the wealth function. Now we run this, and it did finish appropriately. Because the only other input that we're using here is desired cache, and that one we only have a single value for it. So we should be able to run this multiple times, yep, and see different years to retirement each time, corresponding to the different economic conditions which are going on in this run of the model. So the last adjustment that we would want to make here is right now it's not clear which years are recessions, which years are expansion, which year are normal. So we can add that into the print output as well. So we can get the case type. We had that in the data, the case inputs. We're going to look that up by the case. And then we can say case type economy in the output. And now we see normal, expansion, recession. It's showing what type of economy is occurring in each year. And we can see that it changes each time. And when there's more normal expansion, we've got a short years to retirement. When we've got more recessions, less expansion, then it's going to take longer to retire. So then we can take this logic. We don't want the print output part. Take this logic and we can put it back into the function. And we want to make sure that we return the year at the end. And now we should be able to run the full model, and it is indeed working. So now we have it working for the basic model, but whenever you have randomness built into a model, be it internal randomness or adding it externally via Monte Carlo simulation, now your model will give different outputs for the same inputs each time that you run it. So you generally want to run the model numerous times and summarize the outputs from it in some way. So what we're going to do is we're going to make a loop where we run the model multiple times. Um, so, um, and here I'm going to do it a little bit ad hoc. We could also, or let me go back and add the number of iterations into the model inputs as well. So number of iterations, and let's make that 1,000. Oh, whoops, gotta be integer equals 1,000. There we go. And now, so we want to create a list, which is going to store our use retirement. We want to loop for, oh, I gotta make sure to rerun that data cell, get the new data. The number of iterations. We're going to calculate the use retirement. And real quickly, I'm just going to make the number of iterations low just for testing purposes. And so we're running for that number of iterations, and we're going to calculate the use retirement with the data. And we don't want to print the output because that would be a ton of output to be showing, running the model multiple times. And then we want to append the result to our list. Okay, so there we should be getting, yep, now we have some different years to retirement. Already have pandas imported. Let's see. I do. Okay, cool. So then I can put those years to retirement in a data frame so that it's easy to summarize it. So I want to get the average. I want to get, let's see, not just the average. I want to get the standard deviation. I want to get the max, and I want to get the min. So that's STD, max, and min. And let's print that out. It will take the average, YTR, 0 decimal places fixed. Here's retire on average with a standard deviation of FTD YTR. Let's let that have 1 decimal place. Max of max YTR and min of min YTR. And we can break this onto multiple lines because it's really long. I forgot my quote over here. There we go. Okay. And so then now we can try this with the full number of iterations, 1,000 iterations. Run this again. And we see on average 26 years to retire, standard deviation of 1.6, max of 31, minimum of 22. So that gives us quite a bit more information about the retirement possibilities based on the different possible states of the economy. And since we're making this part of the core model, we can also bring all this into functions. So we can make this years to retirement. Let's call it case df, and that takes the data, and it's going to return the data frame. And then we can make summarize years to retirement df. That's going to take the df, and it's going to do this stuff. So then we can have one more function that calls both. So years to retirement cases and summarize, which calls this to get the data frame and then does the summarization. So then we can directly call this years to retirement cases and summarize on the data, and we directly get to that string, and we can try it with whatever other inputs we want. Say we want 2.5 million desired cache, then it's going to take longer. Something seems to not be working there appropriately because it's not adjusting as I pass additional, as I update the desired cache. So let's go back and look. So, aha. I still have this this line that I had just for testing purposes, where it's redefining the data, and that means it's no longer taking the data as an input, it's overwriting it. So let's take that out, rerun that, rerun this. Yeah, now it is working appropriately. If you really needed $250 million to retire, you want to have a really lavish lifestyle, then you're probably going to die before you actually get to retirement. So now everything is working appropriately. So that's how we can add internal randomness to an existing Python model. Again, you generally would want to build this in from the start, and then it would not be such a large effort to build it in. And in most cases, you could use Monte Carlo simulation as an alternative to adding internal randomness to an existing model. So thanks for listening, and see you next time.